Okay, let's talk about an introduction to fluids. So when we think of our body and we think of our body weight, we need to remember that 40% of our body weight is actually solids. The other 60% is our total body water. So 60% of the total water is, out of that, 40% is intracellular fluid. And then 20% of this 60% is extracellular fluid, with 15% of that being interstitial, which is fluid between these spaces of the cells and the vessels. And then 5% is intravascular. So that is fluid that is in the vessels. Okay? So some body water components, we have plasma. There's also, blood would be considered one, but we're going to talk about electrolytes right now. So electrolytes are basically the combination of ions to form a substance that then breaks down into water. So we have intracellular fluid electrolytes, and these tend to be potassium, the magnesium, phosphate. Okay, and then remember from anatomy and phys, we talk about cations are positive ions and anions are negative ions. Okay, then we have extracellular fluid electrolytes, and those are those are sodium, chloride, and bicarbonate. And basically, it's the regulation of electrolyte balance, and that is what causes the absorption, okay? And it's usually the reabsorption of cations. So how it goes is the cations are absorbed first, those are followed by anions, and then anions, and then there is water. So it goes like this: cations first, anions, and then water. Anions, ions, All right, so this is a picture that I drew of what it kind of looks like. So here you have your cells, right? So there is intracellular fluid, and those are potassium and magnesium, okay? Then in your interstitial space here, we have sodium and chloride. Okay. This is intravascular, and you'll see in intravascular you have sodium and chloride here. And then in the extracellular space, we're just kind of seeing here that it's in the cells, okay? And we have the potassium and the magnesium. So potassium and sodium, how these are moved through the body is using a potassium-sodium pump. And this regulates the exchange of the potassium and sodium through the intracellular as well as the extracellular spaces. So it's a little bit different than the osmosis. Another component is plasma proteins, and basically plasma proteins are molecules that are large and have a high molecular weight. And anything that we have that has a high molecular weight, we're going to call a colloid. And we're going to talk more about colloids in another video, but you just kind of need to know that plasma is a colloid. And plasma contributes to osmotic pressure. This also could be called ionic pressure or colloid osmotic pressure. And basically what this does is it is a force that governs the movement of fluids throughout the extracellular space. And just to add in, because I know how much you guys really like talking about this, we have hypotonic solution. So basically when you have hypotonic, there is a decreased amount of solute in the extravascular space, extracellular fluid, okay, in the extracellular fluid. So basically water is going into the cell, so it's enlarging. Here's isotonic, which is where the cell and the extracellular fluid are balanced. And then we have hypertonic, and this is where there's a greater amount of solutes in the extracellular fluid, and then the water is coming out of the cell and into the extracellular space.